Hello, we're going to talk about the difference between paramagnetism and diamagnetism. So paramagnetic, this means that in your orbital notation, you have at least one unpaired electron, which means you're going to have a lot of options on that. Diamagnetic, it means there are no unpaired electrons, which means that there are a very certain group of elements that fit in no unpaired electrons. Now here's the really cool thing. If you have an unpaired electron, it's going to be attracted to a magnet. So that's going to be involved in magnetism. I gave you several examples here. Let me show you. So here's vanadium. I used core notation 4s2 3d10. So you have your full S subshell and then 3 unpaired electrons. Now the significance of this comes from Hund's rule, that an electron will fill an orbital individually, then once all the orbitals in that subshell are filled, then it goes back and doubles up. So you will always have one electron in an orbital until that subshell is filled. So these all have their own orbital. We have 3 unpaired electrons. That would be classified as paramagnetic. Now I went across the second period for a group of elements. Here's nitrogen. I used core notation, helium, 2s2 2p3. Check this out. We are going to have 3 electrons, 3 orbitals. So all 3 of those electrons using Hund's rule are going to be unpaired. That is going to be paramagnetic, attracted to a magnet. Oxygen, 2s2 2p4. So I went up, 1, 2, 3, and then the fourth one, that's where it had to double up since I have 1 electron in each of the 3 orbitals. So this has 2 unpaired electrons. Still paramagnetic because there's 2 unpaired electrons. Let's look at fluorine. So there's helium, 2s2 2p5, my 2 electrons in the 2s, and then my 5 electrons. I went up, my electron's spinning. So that was 3, and then I had 4, 5, spin down. I have 1 electron that's unpaired. That is paramagnetic. Even if you have 1 electron that's unpaired, that classifies the entire element as paramagnetic. Now, let's finish off that second period. Here I have neon. So I did the full electron configuration, 1s2, 2s2, 2p6. Here we have it, 6 electrons, up, there's 3, then I go back, down. That gives me my 6, completely full. That is diamagnetic. There are no unpaired electrons, so it will not be attracted to a magnet. So this means diamagnetic is going to be all of our full subshells. So a full S, if you're ending with the S2, the full P ending on P6, the full D ending on D10, the full F ending on F14. Those are all diamagnetic. Anything else in between there, you have an unpaired electron, it will be attracted to a magnet and be classified as paramagnetic. Doesn't matter if you have 7 unpaired electrons in an F block or if you have 1 unpaired electron, like here is a halogen. That will be classified as paramagnetic. Nice work. Have a wonderful day.